Concerning the correctness of particle filtering, it has to be noted that particle filtering is going to converge to the same result as the filtering forward algorithm in case the number of samples goes to infinity. It can be observed as follows. So first notice that given the assumption that we have a large number of samples, then the probability of the number of samples generated at time t for each value xt of the state as a ratio is supposed to be equal to the probability of that value given the evidence to the time before it. This is the base of the recurrence. Next, during the forward propagation of the samples, when we are going to sample the state t plus 1, the number of elements arriving in a state xt plus 1 is going to be equal with the number of a fraction of the number of states in each previous time frame. So for each state xt, lowercase xt in the previous time frame, we take a from the number of samples there, a fraction given by the transition probability from xt plus 1, xt to xt plus 1. And summing up from all previous states, like it was the case from rain 2 and rain 4, the number of samples coming, we got a number of states that's proportional with this weighted ratio. Now the weights are being added and the weights are given by the probability of the evidence in state t plus 1 given the state xt plus 1 in which you have samples. And with the resampling, we are actually adding the alpha value over the fraction of the samples in the timestamp t plus 1, which corresponds to adding, remember that this number of samples was given by the weighted value of the numbers of samples in each state, where the numbers of samples in each state was computed from here as a weighted sum with the transition probability from the previous states. So when the number of samples goes to infinity, these numbers of samples with appropriate normalization factor, it's equal with the probability of those states given the evidence, and this is nothing else but the formula for the forward algorithm that was inferred in the exact computation with variable elimination at the beginning of the study of hidden Markov models. So it's equal with the desired probability of filter probability of xt plus 1 given the evidence all the way to t plus 1. Concerning particle filtering performance, if with likelihood weighting after 50 frames even 10,000 samples were not sufficient to have any relevant estimation, with particle filtering shown here, the curve that you are seeing on the bottom, the curve for the likelihood weighting, it's particle filtering computation, it's basically flat, leading to high quality evaluation. So you can see the potential of this algorithm being used in robotics to give robust results.